All right, so hey, if you've been following along with us, we've been on this awesome journey,
Yeah.
kind of turning code into like pictures and stuff.
Yeah, turning our screens into like digital art canvases.
Exactly, and we've been really focusing on rectangles lately.
Mm.
Those like simple shapes, but you can do so much with them.
Yeah, and they're like the basic building blocks for like anything visual you want to make with Curd.
Totally. And remember all the cool stuff we did with rectangles, like changing their colors,
Yeah.
adding those gradients, making them see-through.
Yeah, like all that was just a few lines of code.
It's pretty amazing what you can do. And now that we've got a good handle on rectangles, we're going to level up our skills today.
That's right. We're expanding our toolkit, adding some new shapes to our repertoire.
And, we're calling this a deep dive for a reason because we're really going to get into the nitty-gritty of ovals, circles, and lines in Python.
Yeah, all those shapes you see everywhere, in logos, designs, all sorts of things.
Exactly. And the cool thing is, a lot of what you've already learned about rectangles, like how to color them and stuff, it's going to carry over to these new shapes.
Yeah, the concepts are similar, but each shape has its own quirks. Its own way of being defined in code.
And that's what we're here to unpack today, so you can start using them like a pro in your own coding projects.
Exactly. We want to make sure you understand those differences and feel confident using them in your own creative coding.
So let's start with ovals. I mean, everyone knows what an oval looks like, right? It's like a stretched out circle.
Yeah, or a squished circle, however you want to think about it.
And in Python, we use the function oval with parentheses to draw them.
Yeah.
But here's where things get a little different from rectangles.
Yeah. Unlike rectangles, which you position based on their top left corner, ovals are all about their center point.
That's right. So when you use the oval function, the first two numbers you give it are the x and y coordinates of the oval center.
Yeah, so think of it like the bullseye, the very middle of the oval.
And then after that, you tell it how wide and how tall you want the oval to be.
So it's still all about those two dimensions, width and height, just like with rectangles.
Exactly. And the source we're looking at gives a really clear example. It says oval parentheses 150 comma 150 comma 100 comma 200 comma fill equals quote gold end quote.
Yeah, so let's break that down. That oval has its center at the point 150 on your screen.
So if you picture your screen like a grid, that's where the middle of the oval is.
Then it's 100 units wide and 200 units tall, and it's filled with a nice gold color.
And that fill part that should look familiar, that's how we colored our rectangles too.
That's right. And all the other cool stuff we did with rectangles like borders, gradients, opacity, you can do that with ovals too.
So you're already like halfway there. Just got to remember that center point thing.
Exactly.
Okay, now let's move on to circles. These are kind of like the superstars of ovals.
Yeah, they're like the perfect ovals, perfectly symmetrical in every direction.
And what makes a circle special is that its width and height are always the same.
Right. So instead of needing two separate numbers for width and height, we just need one, the radius.
And the radius is the distance from the center of the circle to any point on its edge.
Like imagine you're drawing a circle with a compass. The radius is the distance you set on the compass.
Exactly. And in Python, the circle function keeps things nice and simple.
Yeah, the source gives us this example. Circle parentheses 100 comma 200 comma 50 comma fill equals quote green end quote.
So just like with ovals, the first two numbers, 100 and 200, tell Python where the center of the circle should be.
But then we just have that one number 50, which is the radius.
One number to rule them all.
Exactly. And what's really cool is that radius determines everything about the circle's size.
The source actually has some really thought-provoking questions about this. Let's see if we can answer them.
Yeah, let's put our circle knowledge to the test.
All right, so first question in the code above, what is the circle's leftmost point?
Well, if the center of the circle is at x-coordinate 100, and it extends 50 units to the left, that's the radius.
Then the leftmost point would be at 100 minus 50, which is 50.
Exactly. So the leftmost point is at 50 on the x-axis.
All right, next question in the code above, what is the circle's topmost point?
Well, if the center's y-coordinate is 200, and the radius extends 50 units up.
Then the topmost point is at 200 minus 50, which is 150.
Right, so the topmost point has coordinates 50, 150.
Okay, now for a more general question, what is the leftmost point of a circle with radius r centered at x, y?
Well, we just figured out that it's the x-coordinate of the center minus the radius.
So that would be x minus r, y.
Makes sense. You just shift the x-coordinate to the left by the length of the radius.
Okay, another one. What is a circle's width in terms of its x, y center and its radius r?
Well, if the radius is the distance from the center to the edge, then the total width is just the radius on one side plus the radius on the other side.
So it's 2 times r.
And because the circle is perfectly symmetrical, the height is also 2 times r.
That's what makes circles so elegant. Just one measurement.
Mm.
The radius defines everything.
Absolutely.
All right, let's shift gears now and talk about lines. These are a bit different from the filled shapes we've been working with.
Yeah, lines are all about connecting 2 points. Think of it like drawing a straight line with a ruler.
And to draw a line in Python, we use the line function, and we need to tell the coordinates of the starting point and the ending point.
Exactly. The source gives us a simple example. Parentheses 50, 100, 75, 200.
So this tells Python to draw a line starting at the point 5100 and ending at the point 75200.
And you know what's really helpful? The source mentions the inspector tool.
Oh yeah, that's super useful when you run your code. This tool actually highlights the 2 endpoints of your line.
So you can visually see exactly where it begins and ends. It's great for double-checking your work.
Absolutely. Okay, now the source asks a good question. Can a line be drawn the other way switching the endpoints?
Well, if you're just drawing a straight line, does it really matter which point comes first?
I don't think so. The line connecting those 2 points is still the same line, right?
Exactly, and the source confirms that it gives us this example line, parentheses, 75, 200, 50, 100, fill equals, quote, orange, end quote.
So it's the same line, just defined with the endpoints in reverse order, and they even colored it orange, just to show you that you can still set its color.
And that actually brings up a key difference between lines and the other shapes we've talked about.
What's that?
Lines don't have a border property like ovals and rectangles.
Oh, that's right. If you try to use border with a line, you'll get an error message.
The source even shows us the message. It says, exception : cannot set lines border.
And that's actually a pretty helpful error message. It tells you exactly what went wrong.
Yeah, instead of border for lines, we use fill to set the color of the line itself.
So think of it like choosing the color of your pen or pencil.
And if you want to make your line thicker or thinner, you use the line width parameter.
The source gives us this example. Line parentheses 75, 200, 50, 100, fill equals, quote, orange, end quote, line width equals 8.
So that'll create a nice thick orange line. The higher the line width value, the thicker the line.
Got it. And one last cool thing about lines, we can make them dashed.
Oh, yeah, that's fun. You can do that by setting the dashes parameter to true.
And that'll give you a default pattern of dashes and gaps.
Or if you want to get really fancy, you can use a tuple, like dashes equals parentheses, dash width, comma gap with end parentheses.
That lets you control the exact length of the dashes and the spaces between them.
It's like having different kinds of dotted or dashed line styles.
Okay, so let's recap what we've learned today. We've got rectangles, ovals, circles, and lines.
Quite a collection of shapes.
And the big takeaway is that rectangles, ovals, and circles are all about defining an area.
Whether you're using corner points and dimensions or center points and dimensions or a radius.
But lines are different. They're all about connecting 2 specific points.
And remember, lines don't have a border. You set their color using fill and their thickness using line width.
It's like they're a path rather than a solid shape.
And even though lines use fill for their color, they're still super important in visual design.
Yeah, you can use different colors and line widths to create emphasis, show direction, add texture, all sorts of things.
And you can even play with opacity to make your lines semi-transparent, just like with the other shapes.
So many possibilities.
So now that you have all these shapes in your Python toolkit, what are you going to create?
Yeah, think about how you can combine these basic shapes, rectangles, ovals, circles, lines, to build something amazing.
What kind of visual stories can you tell? What kind of designs can you bring to life?
That's the challenge we're leaving you with. Get creative, experiment with all the different parameters, colors, positions, see what you can come up with.
The world of visual coding is your oyster.
And we'll be back with more deep dives into Python and graphical design soon.
Until then, happy coding.
Keep creating!